Okay, now just in time or JIT system. Okay, JIT means that we don't have our inventory on hands. Whenever we want to use the material, we just call supplier. So there are three relationship between quality and JIT. First, JIT cuts the cost of quality. So when how it cuts the cost of quality, cost of scrap, cost of rework, cost of storage, storing the inventory or inventory investment, and damage costs are directly related to inventory on hands. What we have lah inventory ni, apa yang kita simpan. Because there is less inventory on hand with JIT, and costs are lower, so we don't need to build our own storage, we don't have to build a bigger warehouse. So that's how we reduce cost. At the same time, cost of rework can be reduced. Okay, and in addition, inventory hides bad quality, whereas JIT immediately expose bad quality. So once we can identify the bad quality ni, so kita akan improve lah the next time. Okay, and second relationship with between quality and JIT. So JIT improve quality. How? As JIT shrink or shorter the lead time, it keep evidence of error fresh and limit the numbers of potential sources of error. So we can trace the error, and then we can the next time. So we will take corrective actions lah, ataupun we will improve in the next time. So JIT creates in effect an early warning system for quality problem both within firms as well as vendors with the vendors. So we can take actions lah towards the warning tu. Okay, the third relationship between JIT and quality. So it will provide better quality means less inventory and a better or easier to employ JIT system. Okay, it often the purpose of keeping inventory is to protect against poor production performance resulting from unreliable productivities. So that's why we keep the inventory tu. So kita simpan inventory because of kita nak cover ataupun to protect against poor production performance. Barang tak jadi, kita buat-buat terpaksa reject. So it is a poor performance of quality lah, or unreliable quality. That's why kita lebihkan barang, adakan the inventory tu. And now once we use the JIT system, so we can cater this problem. So if consistent quality exists, JIT allows firm to reduce all the costs associated with inventory. Okay, JIT is a pull system in manufacturing that involve producing only what is needed and when is needed. So that's why supply chain or supply management involved here. Meaning that productions only when signal lah, when it is needed. And the second part, it allows reduce inventory level where inventory costs money and hides process as well as material problems. When we have too much inventory, so we do not know what do we have and what we not have in inventory. So kita akan beli lagi barang, because we do not have a proper inventory. Okay, and encourages improve process and productivity, product quality once we use JIT system. Okay, here is JIT example. Okay, so this is the problem. For example, what we have in inventory: unreliable vendors, scrap, capacity imbalance, which we do not know the problem is there. So kita nampak this only the problems that we can identify. Okay, so how if we reduce the inventory, it will reveal the problem so that it can be resolved lah, the problems of unreliable vendors, scrap and capacity. So this water is imagine that this is inventory. We do not know the problem under the water under the ocean. Okay, imagine that this water is can be reduced, so we can see the problems lah underneath the water. Okay, and next we move to Taguchi concept, whereby it is in engineering and experimental design methods to improve product and process design. We want to identify key components for Taguchi concept. The need to identify key components and process variables affecting a product variations. What will affect or what affects product variations in production? Okay, and in Taguchi concept, emphasize these three things: quality robustness and quality loss function, as well as target oriented quality. Okay, let's go through the quality robustness under Taguchi concept. The quality robustness is the ability to produce product uniformly or in standards in adverse manufacturing and environmental conditions. So quality robustness, we want to remove the effects of adverse conditions and also small variations in materials and process that do not destroy the product quality. So it will not affect the functions ataupun the means, the use of product itself. Tapi kita add the new functions in quality the of the product. Okay, we have quality loss function. Under Taguchi concept, it shows that cost increase as the product move away from what the customer wants. So it will not meet customer wants lah. That's why we need to do R&D in the innovations on that. So cost is running there. So costs include customer dissatisfaction, warranty and service, internal scrap and repair, and cost to society. Cost to society can be the image. Do not buy this product because of it will not last longer, for example. Okay, so that is the cost lah. Kit and traditional conformance specification are too simplistic. So this is what we want to counter the quality loss functions. Now we move to tools of TQM under the concepts of quality. Okay, then tools. First one, tools for generating ideas. So tools of TQM we can use to generate idea, to organize data. So tools for generating idea, for example, check sheets, scatter diagrams, cause and effect diagrams. And for organizing data, we use Pareto charts and flow charts. Okay, the use of tools of TQM, the other one, to identify problems lah. So by having histogram and SPC, statistical process control charts. Okay, here is examples of check sheets and organized method of recording data. So here we can see here defect, what kind of defect the defects area ataupun the defects of the product A, B or C, and hours lah. So dia akan record. It will be recorded. And second part is scatter diagram, whereby a graph of the value of one variable versus one another. So for example here, productivity and absenteeism, meaning that worker will not productive, the productivity will low, and because that's why absenteeism happen. Okay, and we have cause and effect diagram, tools that identify process element, cause or causes that might affect the outcome. So for example here, this is the effect, this is the cause, and for example, cost of material, cost method, manpower, we don't have manpower, we don't have enough machine. That's why the productivity decrease ataupun quality decrease. Okay, and Pareto chart is a graph to identify the plot problems or defects in descending order or frequency. So these are descending order lah, what they call it, descending order, and this is the frequency. Okay, flowchart is a step-by-step. It's a process. It shows step-by-step process. Histogram, it is a distribution showing the frequency of occurrence of variables. So where it shows, this is example of frequency and repair time. So this is the histogram. And this is a statistical process control chart, where a chart with time or horizontal axis to plot values of the static. So they do have upper control limits, target value, and lower control limit. So when it is under the low or lower control limit, it is not good to use the product. The product that's not meet the quality requirement. Upper control limit, it is under out of your control. So within this target value, the product, it is the product defined is very good to on statistical process control charts. Okay, this is examples of cause and effect diagram, whereby it is the cause is miss free throw. So the method, the material, because of the ball, might be the size of the ball, grain field, air pressure, and lopsidedness. For methods, maybe because of aiming, shooting process, because of aiming point, bending, balance. That is on methods. On machine, on manpower, it comes from training, consistency, concentration, motivations of workers. This is on machine hook or backboard. Okay, so these are the problem. Okay, this Pareto chart. This is examples of Pareto charts, and this one is flow chart. It shows a step by step of MRI process. Statistical, use statistic and control charts to tell when to take corrective actions. There are 40 key steps to measure. First step, measure the process, and then second, when a change is indicated, find the assignable cause and eliminate or incorporate the cause, and restart and revise the process in order to take corrective actions. These are examples of SPC charts.